x be 0, you get y equals 0. And then if you set y equal to 0, you'll get x equals 0. They're both the point 0, 0. So that's not enough, obviously, to graph it. But beyond just finding intercepts, what's the most basic way to graph any given equation? What's the most basic way to graph? In fact, what is a graph of an equation? All the points that it goes through must do what? What is an equation when you graph it? What must happen with all the points? They make a line. If it's a linear equation, I agree with you. But all those points must work in the equation, right? So that kind of tells you where to get points from. You find points that actually work. And what's the easiest way to get points that work? Plug stuff in. So what do you get when you plug a 1 in there? Yeah, negative 6 times 1 is, so y would be negative 6. When you plug a negative 1 in there, you get, yeah, negative 6 times negative 1 is positive 6. And we already did the one, when you plug a 0 in for the 1, the other one comes out to be 0. We just needed one more, so now you can say 1 goes to 6, golden. And of course, negative 1 would go to negative 6, cool. So don't get hung up on one method or the other method. Sometimes the intercepts are really just singular. There's only one intercept, the origin. Then you have to plug in to get one more point. Cool. Okay. Any other questions from homework? You guys doing okay? Y'all look a little defeated. I don't want you to feel that way. No other questions from homework? Okay. What I want to do is kind of, obviously I want to go over that worksheet that we got last time. Should have worked in groups on that last time. There was a front sheet which is mostly review, 3.1, 3.3.3. And the back of the sheet was section 3.4, just the part that should have been lectured over last time. Right? So let's kind of go step through this worksheet. And let me see. Those are the bad ones. Those are the good ones. Bless you.
I do have one more question.
Yeah.
21 on 207.
Oh, cool. I like this example. You got this little hill. Here's the top of the hill is 32 meters up. And it takes you 108 meters to get to that height. And we're approximating this side with a straight line. So they ask you, what is the slope or the grade? And that's really the word. Say again?
I'm sorry, what's that?
Oh, this is page 207, section 3.3. So this is a nice physical example of a problem that we talk about in mathematics, but we see this all the time. This is the thing, I think a few of you guys agree with me. You've seen those signs that say 7% grade ahead, 10% grade. 10% grade would be crazy, but those exist. Those are pretty steep down or up, depending on which way you're going, and those are where they have the runaway truck ramps. A little scary when you first see that. Remember the first time I saw that? I grew up in Florida, okay, and the only thing the ground does is go down for sinkholes. It doesn't go up much. So I didn't really see a mountain or anything like that until I was 17, I think, right? Lived in Florida, up the East Coast. Finally made it out on this huge trip, and then I was in Colorado, and I was just, holy crap, I was not used to the ground going up. So I didn't really see this a lot, but around here you see it in some places like Mission Hills is stupid hilly. The name kind of gives it away, but you see these crazy grades there. So this is a physical interpretation of this idea of slope. So what is slope? This problem ends up not being evil if you just remember the less mathematical definition of slope. The more English definition of slope. What is slope?
Rise over run.
Rise over run. How much from this point to that point? How much do you rise? How much do you purely rise?
32.
32. You would be 32 meters over anybody who is still at the base. Some little dude down here. Hey man, what's going on? And I'm way up here. I'm gonna throw this penny on you. No. So 32 up. And how much do I run to get that high? 108.
So it's just 32 divided by 8.
And then you can reduce that. Yeah, cool. Is that cool? Okay. So again, I love that whenever it's possible, there are physical analogies to some of the stuff that we do in this class. Sometimes there aren't yet, because in the real world it's more complicated than some of the math that we talk about here, right? Because the real world obviously is pretty damn complicated. So sometimes I can't quite directly relate what we're learning to the real world because we're learning stuff to build up to the more complicated situations. This is a really good example of a real world problem. You just reduce that. Any other questions? Yeah.
Section 3.4, number
3.4 number
question number
80?
Yes.
Oh yeah, good. Page 220. It costs $2,000 to purchase a copier and 2 cents per copy. Where'd it go? There it is. So this one, they have a little description at the beginning. They have fixed cost and variable cost. So we see the situation. This is one of the most classic situations in real life of a linear equation. For example, you go to take a taxi. Isn't it, there's some formula. You pay this much for the first eighth of a mile, plus this much for every mile thereafter or whatever, right? So there's a fixed cost for the first eighth of a mile, plus something per mile after that. Or you call the plumber. Dude, come to my house. Okay, it's $100 right out the bat to get me there, plus $20 an hour on top of that, whatever. That would be a pretty cheap plumber, but you guys kind of with me here?
Mm-hmm.
So which piece of that changes? That's the variable cost. In this case, what's the fixed cost? What do you only have to pay once? Thank God.
$2,000.
$2,000. So that's the part that's not going to have a variable on it because it doesn't vary. That's the part that's fixed. So how much does it cost me overall if I make some unknown number of copies? So let's do some specific examples. How much will it cost me if I make 100 copies? Total cost.
100 equals the 0.02x plus 200.
So let me catch up to you a little bit. So it's going to cost $2,000 to buy this copier. Now this is a funny morning. I'm going to make 100 copies. Let me go buy a copier and then make copy. You know, that's a little crazy. Just go to Kinko's. But let's just pretend that we want to go buy our own copier. So we got to pay $2,000 off the bat plus 2 cents per copy, and that per is a magic word. If it's 100 copies, how much extra money on top of the cost of the copier is there? How'd you get that? It's 0.02 cents times 100. Right, $0.02. 2 cents per times 100 sheets. Cool? So that per really kind of gives you an idea where the variable should go. If renting a truck, which is near and dear to my heart because I'm going to be moving soon, if I want to rent a truck and they say it's $39 plus, let's just say, to make it easy, 50 cents per mile. A little high, but oh well, too bad for me. Right? Where's the variable going to get stuck? Where am I going to put the variable? On the mile. So it'll be $39 plus 50 cents per mile. I don't know how many miles I'm going to go. That's where I have to put the X. If I go 2 miles, why the hell did I get a truck? 2 miles is a little crazy. If I go 2 miles, 2 times 50 cents is a whole buck. So it costs me a total of $40.
You wish.
For the, is that section,
Or is that part 8 of 80 when you pick the 100?
Yeah, I'm sort of making my way there, right? So now we can go back and answer these specific questions. Which part of this is the fixed cost? Which is the one I'm going to only have to pay once? The 2,000. Thankfully, I don't have to pay 2,000 per copy. That's damn good paper, right? So let's say $2,000 is definitely the fixed cost. What's the variable cost? Should be the part B. Yeah. Variable cost.
Oh, it's just a 2 cents.
2 cents, because it's 2 cents per copy. Let's see. Write the cost equation. So the cost is going to equal definitely what? Even if I don't make any copies, it's going to cost me $2,000 just to get this thing in my house. Plus 2 cents per copy. And how many copies am I going to make? No, that was a specific example. Do you know how many copies I'm going to actually make? No. So X.
Okay.
This told me where the variable should go. If I'm going to make 100 copies, I put 100 there. Oh, I'm going to make X copies. X better go
The thing you don't know.
there. Exactly. Cool. There's my cost equation. Now, on one level, this sounds like a lot to go into what ends up being a pretty simple equation, but you have to realize, I'm hoping you guys realize this, this is a direct, real-world place to use linear equations that we're learning about right now in math. So the biggest complaint about math is there's nowhere to use it, and that is very easy to show that's wrong. Yeah?
For the same problem, but part D, that still needs to add the price of the copy machine, right? Or just the profit?
So here's our cost equation. Move along. Where are you? Did somebody close that door? Thank you. Alan, thanks. You set up the cost equation here, now they're asking you to use it, right?
Yeah, but, okay, so we just keep the
Exactly. So you still assume that you got to pay for that copier, right? So for part D, it says, what's the cost for 10,000 copies?
So you just times it by 10,000.
Where would you put
When you do
10,000?
the X.
You put 10,000 right there for X, exactly. Because X is the number of copies. That's what I go in not knowing. I like it.
So for E, do we fill in the 2,600 where the 2,000 is?
No.
Sorry, wait.
2,600.
So real quick, for this one, just to make sure everybody's cool with this, cost equals 2,000 plus 0.02, 10,000, right?
Yes.
So that should be 2,000 plus 200, right? So that's $2,200. You guys see that? Just plug the 10,000 in for the variable. Now I know I'm going to make 10,000 copies. What's the difference between that and part E? X represents what again?
How many copies?
How many copies? And this is cost. So in part E it says how many copies, I don't know. So I can't put a damn thing there. How many copies will be produced if the total cost comes out to be $2,600? So where would I put 2,600 for part E? Yeah, and for cost. So cost equals 2,000 plus 0.02x. In the place of cost now I'm going to put 2,600. And now I need to solve for x. So
Minus 2,000.
Yeah, exactly. Now it's a simple equation. I appreciate your giggling because this sounds very complicated on it, but it's not really. Once I've set up my equation, I know where to put what. If it's a cost, I put it in the place of cost. If it's a number of copies, I put in for x because x represents the number of copies. So how many of you guys ride the bus? Because I rode the bus for a while when I first moved here. Nobody rides the
Have
bus.
you ever? Is that your question?
Sure. How many of you guys have ever ridden the bus in San Diego? Okay. How many of you guys have ever bought the little monthly pass? Anybody? Okay, good. All right, you're with me now. Good. There's a certain amount of bus trips where the pass becomes the better way to go than to pay for the bus trip itself. You with me?
Yeah.
To figure out exactly where that is, you need mathematics. You need to represent the total cost if I bought the pass. Well, that one's easy because it's just a set cost, right? There's no variable cost there. And you have to set up how much would it cost me to do it each time. And then you set those equal. And you can see how many trips would make it worth my while to buy the pass. You guys kind of with me?
Yeah.
This is the type of real life problem where you can immediately use the math that we're talking about. Okay, now there's obviously a lot more complicated situations where you've got to use some further math that we'll learn soon, but you can already start using this stuff. For example, we're moving soon. I'm not going to be able to use the gym. I live in North Park. There's like a North Park gym. So I was paying money to go there. And now I want to sit down at some point and figure out, was it worth my while to pay more money up front? So there was something like you pay $200, and then it's only $29 per month. Or you pay $300 up front, and then it's only $19 a month. I'm simplifying it, but you guys kind of with me?
Yeah.
So you can figure out, well, how many months do I think I'm going to be going here? Would it be better to pay this one or this one? You with me? So we're going to figure that out right now. Right now, this isn't exactly the numbers, but let's figure this out based on this. Because I want to show you, this is a real life problem. So what would the cost, let's call this option A and option B. So for option A, what's the fixed cost? $200. I got to pay, that's like intro fee or whatever the hell they call it. Right, the $200. The cost for this option is $200 plus, what's the variable cost? $29 per month. So what goes here? X. So we'll call this, we'll give it a better symbol than just cost. We'll call it A, because it's option A. Jeff, that is creative. I know. What about option B? What would it look like? $300 fixed cost plus $19 a month. Now you guys try it out. Set them equal to each other. Try it. Set them equal to each other and see how many months would I want to go one way or the other.
So do A equals B?
Exactly. You see, this is the whole idea of the break-even point. You know, they tell you, buy solar panel. You have to pay so much money now, but in 5 years, it'll pay for itself. That means the savings you'll have over 5 years supposedly offsets the amount of money it costs to buy the thing in the first place. You guys have all heard this kind of thing, right? You might not be considering solar panels, which I'm not either, I understand, but still you've heard it. This is not a very...
I got X equals 10.
I like it, right? Subtract the 19. You get 200 plus 10x equals 300. Subtract the 200. I get 10x equals 100. Divide by 10. I get x is 10. And we should all be able to do that. And this is, of course, the reason why I make a big deal out of units and all that stuff. Is that 10 days? Is that 10 years? That's 10 what? Months, because it's per month. So my x must be number of months. 10 months. So if I know I'm going to move in 8 months, this is the tricky part now. If I know I'm going to move in 8 months, which one do you think I should choose then? The one where I got less to start with, right? This one becomes better to pay this much money because if I wait 10 months, this is going up quicker than this. Are you guys with me? Isn't the amount of money I'm paying here going up quicker? It's less than what I'm paying here, but it's going up quicker than this one is over a period of months. So what does that relate to then, this piece of this equation? What x plus what? This is what Kelly should have talked about last time. mx plus b, right? Isn't that the slope? Isn't that how much it goes up by? Even without talking about m and b and lines and slope. If I just said, this one costs you more, it rises quicker than each one, you would know what the hell I was talking about. You would know it. There it is. But that's what slope means. How quickly is it going up? So very quick, rough sketch. Here's 100, 200, 300. Here's the 200, and here's the 300. But the 300 has what slope? How much per month? 19. And the 200 has 29. So that's the point that we just figured out by setting them equal to each other. When is that one going to catch up with that other one? So if I'm going to be there less than this time, I want to go, which option is which? This is A, this is B. I want to go with option A. If I'm going to be in my house for a year or more, I'm going to go with option B. More money up front, but less each month. Okay. Good, good, good. So I've got more people interested in what the hell I'm saying. I like that. But I mean, this is, it's not, sometimes as a math teacher we get stuck in the math a little too much, and what you guys really want is, how the hell does this shit relate to me? And I don't blame you for that. That's exactly how you should feel. So I've got to remember to bring that in every now and again. This is what you could do right now with what you know. Okay. Right level, yeah. Okay. Try to remember what got me into all that here. Here, do me a favor. I'm gonna get back into section 3.4, but I want you to help me out. So finish this table here. Just do that table for me. Let me do this and then we'll do this worksheet. No, it's okay. Don't have to graph. So what are you guys getting when you plug a -1 in? -3 minus 5 is -8. You plug a 0. 0 minus 5 is -5. Plug a 1. -2. And you plug a 2. 1. Now notice something interesting about this. Actually, let's go ahead and graph this. Why not? Let's be quick. Why not? Horrible scale, but oh. So -1, 1, 2, 3, 1, 2, 3, -8. Okay, that's exciting. All right. So -1, -8. So -1, -8. 0, -5. 1, -2. 2, 1. Cool, man. It's actually pretty straight for me.
Mine wasn't straight.
What's that?
So mine wasn't straight.
Aw. So I want you to notice something in both. First off, how do I find the slope from my picture? Count. So starting at this point, how do I get to that point? How much do I have to go up? 3. And then how much do I have to go over? 1. So what's the slope here? 3 over 1. I love it. Here's the cool part. How much does x change from here to there to there? It changes by 1 each time, right? And you can see it. If x changes by 1, how much does y change by? 3. 3. It goes up by 3 each time, right? You can see it in the xy table. You can actually see the slope. If x changes by 1, y changes by 3. If x changes by 2, y better change by 6. Hey, it does, right? How you guys doing? Notice, where is the number 3? It shows up in a few places in the work I've done. Where does it show up in the equation? It's right there.
Right where?
Right there. And that's what I call my amplifier. Right? It's my multiplier. It's whatever x does, what's y going to do 3 times as much? Do you guys see that? The minus 5 really just makes it drop 5. You see how it dropped 5? In fact, that minus 5 is really, when I make x 0, what do I get? Minus 5. In fact, if I would have put a 7 there, I would have gotten a 7. Whatever the hell number is right here has got to be the y-intercept. Because when I make x 0, that thing is left. That's easy to explain, why this number will always be the y-intercept. Whatever number is right there, when y is by itself. Right? This is the one that's hard to buy into, that's the slope. Now, it happened to come out to be 3 here. It doesn't prove anything, really. But notice, y does 3 times what x does. There it is. So when x changes by 1, y will change by 3. Isn't that exactly what the slope is? So if I had y equals 1/2 x, if x changes by 2, y would change by 1. It would be 1/2 of what x does. So in general, whatever number is here when you solve for y is the slope. Whatever number is here when you solve for y is the y-intercept. And that's why this is called what form? Slope intercept. Yes, math people are very creative. What do we call this thing? Slope intercept. Yeah.
I know, I forgot. I was trying to word it.
Oh, sorry. I talked too much. Okay. So with this in mind, let's look at this worksheet together. Thought I had more, but I guess not.
Okay, I have a quick question.
Yeah.
So, instead of solving for the y equals 3x minus 5, would we be able to just start with the graph and put...
Yes, we're getting there.
Okay.
And again, depending on your math backgrounds and how long it's been since you had math and all that kind of stuff, a lot of us know shortcuts or we know further things. We're not there yet.
Okay.
That's where we're coming very soon. Yeah.
We weren't here last time. Can we get a copy of the worksheet?
I was just looking to see if I had more. I thought I had more. Oh, here, yes. Yay! You guys and you. Uh-oh, crap.
Are you gonna be sharing them?
No, this is just for you. You share. All right. So hopefully number 1 went pretty well. Well, number 1, where you had to plot the points, that should have went pretty straightforward. So 0, 2. Let's see. Just so everybody has all the answers here. So in a test or a quiz, I will give you a little piece of a graph there, right? You can make the scale whatever you need it to be. 2, 4, 6, 8, 3, 6, 9, 12. But most of the time I'll try and make it 0 through 5, 0 through negative 5. 0, 2, don't move in what direction?
X.
In the x direction, I only go in the y direction. There's 0, 2, there's A. Negative 3, 5. So negative 3 back on the x, 5 on the y. What quadrant is that?
2.
Second quadrant, like 1, 2, 3, 4, counterclockwise. Negative 2, negative 3. So again, back 2, but this time down 3. 4, 0. What axis will that end up on? 4, 0. Good, the x-axis. 4 and not up or down at all. So there's 4, 0. and then E is 1, negative 3. So 1 on the X, 3 down. That's it. Don't connect these, by the way. It's not supposed to make a picture of Snoopy or something. Right? So don't connect those. Number 2, hopefully also went pretty well. Because on number 2, I didn't make the equation as pretty as I could have on purpose. So number 2 is this equation here. No, it's 3. Okay. And I gave you this, and this. Okay. So the one that throws people off sometimes is this, because we get so stuck thinking that our X is the input. But it's not really necessarily true. I could put something in for Y, and of course something would come out for X. It really, truly doesn't matter which variable I plug stuff into. As long as I know one of them, I'm going to know the other one. Right? So to do the first piece, where would I put 2? Exactly. 2 goes in for X. So I get 4 minus Y is 3. So Y is 1. This, of course, 3 is going to go where? To the Y. 2x minus 3 equals 3. You guys see that? Add 3, divide by 2, x is 3. How are we doing so far? Okay. And then here, again, negative 3 is going to go in for x. Negative 6 minus y equals 3. Add 6, divide by negative 1y equals negative 9. Good. And then this one's nice. I could probably get away with a little bit here. If you put in a 0 for x, that just takes that away. Divide by negative, you get y is negative 3. Good. Now, just to show you that you don't have to force the situation to see this, what do you get if you solve this for y? Can you solve that equation for y? How would you do that? All right, subtract 2x. I like it. So you get negative y equals negative 2x plus 3. Do you see how I kind of force it to be in the form I know I want it to be in? mx plus b? Mm-hmm. So put the negative 2x first.
2/3.
Oh, be careful. I'm not going to necessarily look for an intercept yet. Kevin's trying to get ahead of me. What's the next step to get y by itself?
Divide by negative 1.
Yeah, divide by negative 1. So you get y equals 2x minus 3. Is the y-intercept negative 3? Can you see it in the table? Where's the y-intercept in the table when x is 0? Y is negative. There you go. The y-intercept. When you solve for y, that number will be the y-intercept. And do I see when x changes by 1, y should change by twice that? Do you see that from the equation? Here's a situation where x changes by 1. You guys see what I mean when I say that? 2 went up by 1. How much did the y change by? There you go. Exactly what it's supposed to be. This is rise 2, run 1. That's what that would be if it was a slope. And sure enough, it rose 2 while it ran 1. Okay. Because it's really easy as a student to see this and to lose touch with what the hell, where it came from and why it means what it does, right? It's like, I don't know, this dude told me freaking M is slopes. That's what it is. But I'm hoping you guys can now understand it better than that. M is the slope because that's what it's got to be. It's y changes by m times as much. Rise, run. That's exactly what the slope should mean. And when I set x equal to 0, what do I get for y? B. So whatever b is the y-intercept. Automatically. Cool. Okay. So we went a little bit beyond what it says on here, obviously. Number 4 says find the intercepts. How do you find the y-intercept? for anything in general. Set what equal to 0? X, Q. Q. To find the y-intercept, set x equal to 0. Alright, so if I make x equal to 0, for some reason I always have somebody tell me that this is 3. Right? It's a really easy mistake to make. I'll tell you honestly, just cover that. Right? Make x 0, that piece goes away. So this is negative 5y equals negative 15. Y would have to be 3. Divide by negative 5, you get 3. What do you do to find the x-intercept?
Set y to 0.
Set y equal to 0. So never forget that. I don't care what level of math you're in. I think I already told you this. To find whatever intercept, you set all the other letters equal to 0. We only have 2 letters here. So to find the one intercept, you set the other dude equal to 0 and vice versa. Right? Never forget that. It doesn't ever change. So it'll be 3x. This piece will disappear. Right? 5 times 0 is 0. 3x equals 15. So x is 5. Cool. I'm going to do something finally, silently, and I just want you to tell me what mistake I'm making. You ready? And C. So what mistake have I made? Where is that point coming from? What point is that? What point is that? It's the 0.53. Where did I get that point from?
You put the x and y, you put the solution together.
Exactly. How many points did I just find? 2. This doesn't mean 5, 3. This means 5, 0. And this is 0, 3. Do you see that? So I am one of those teachers that I'm not going to take points off if you don't do this, but I highly suggest that you always write your intercepts as points. So you don't make this silly mistake. You're like, which way? And then I suddenly have somebody just draw a line. At some point they said, screw it, I'm just going to put a line in. I got a chance, right? I'm like, man, you must go to a lot of casinos. So here's 0, 3. And this one would be what now? 5, 0. So now you can plot 2 points. You need 2 points to make a line. Thank God. There's your 5, 0. There's your 0, 3. There's my line. Cool. Yeah, cool.
Just out of curiosity, what did we do with the negative 15?
Oh, what did I do with that?
It's negative.
Oh, it's negative here. I don't know why. Shoot. So this should be where? Other side, thank you. I left off my negative. Better, thank you. So don't ever give yourself a situation where you've done all this work, but you think you only got 1 point out of it. You actually got 2 points out of that. Yeah.
Okay, so pretty much the same stuff we're doing, but what if it's a fraction for the x? When we're plugging in 0 for, if, like, for example, number 21 on the homework on 3.2,
Yeah.
says y equals 1/3 x minus 2. And the question is, find the x-intercept and the y-intercept for the equation. So, would I plug in 0 for the y-intercept as -2? -2 would be 0? Is that what
Now don't go too far with this. It's independent of the equation. What do I always do to find the y-intercept? I make x 0. To find the x-intercept, I make y 0. I don't care if there's fractions in there, or decimals, or square roots. I don't care, right? It's always the same idea. And you're thinking that it's going to be ugly when actually you're going to get 2 nice answers, believe it or not. Because if I make x 0 to find the y-intercept, x equals 0, So y equals negative 2. In fact, you can see that from mx plus b. I know that's the y-intercept, right? So that's the point 0, negative 2. To find the y-intercept, x-intercept, I set
Y.
y to 0. The other dude equal to 0. So that'll be 0 equals 1/3 x minus 2. I'm hoping that none of you write that and just say, screw it, I'm going to go on, and hope he misses that when he grades my homework. Don't freak out about a stupid fraction. Don't. Solve it. How do I get, what do I want to do first? Add 2. How do I kill 1/3? Multiply by 3. See? So you get x is 6. So you actually end up with 2 nice points. What's the point here?
0.
X is 6 when y is 0. I like it. See? Good. The minute you set one of the variables equal to something, that will be part of your point. And then you come out with the other variable, that's the other part of the point. Don't ever forget both parts. Right? Okay. Okay. How you doing? Oh, good. You're going okay. Let's see, where are we at? Number 5. 5 uses the algebraic definition of slope. Who remembers what the, I have m equals rise over run, but what is it in,
Change over Y.
I like it. y2 minus y1 over x2 minus x1. Rise over x, rise over run. Y's over x's. Rise, y's. The other one I can't, I don't know. The other one is
Process of
wrong.
elimination.
So now you just got to plug and chug. And if you want to, this is not necessary, but if you want to, you can call one of them x1, y1, and the other one x2, y2. Do you notice how it really doesn't matter which one you call which? It will turn the top and the bottom around, so the negative signs will still cancel if they need to, right? It'll still come out to the right sign at the end
As long as you subtract one from each.
in the same direction.
Yeah.
But if you do label them, it will make sure you don't make that mistake, right? If you label them, it becomes much more of a plug and chug. What's y2?
Negative 7.
-7. What's y1?
Minus 5.
5. x2 minus x1. Yeah, so you get -12 over -8. The negatives cancel. It reduces down to 3 over 2. I like it.
What number was that one? 5 on.
Number 5 on the worksheet.
Oh. Oh, gotcha. That was perfect.
Oh, sorry. Here's number 6. So I give you a graph. Let me see if I can do this really quickly. Where's it at? 5. It's there. Yep. 6 and -6, 5. And then it's on there at 2. Okay. I want to know the slope of this line. So again, this is just one where you just have to. How do I find the slope? If I give it to you visually, you don't have to use y2 minus y1 business anymore. You can just use rise over run. How much do I have to fall in this case? 1, 2, 3. So I have to go down 3. And how much do I run? 6. Yeah, 1, 2, 3, 4, 5, 6. Right, I'm 6 away from there. Are you guys cool with that? So what's the slope going to be then? Yeah, fall 3 over run 6, which reduces to with a good 1/2. I like it. Now watch what that means. If I go down 1 over 2, down 1 over 2, down 1, over 2. See, so that if it reduces, that means there were smaller steps I could have taken. Do you see that? So if I want to go from here to there, well, I could go all the way and over, or I could go over and over, over, and then we do this all the time living in San Diego. Certain times of day, I don't want to take this street, I want to take these streets, because this street is going to suck. Right? Okay, so we change our, we end up going the same slope, we just change how many little steps we take to get there. Yeah?
So when you're finding the slope, you always have to go down first?
No, definitely not. I could have gone, I could go up. How much would I go up from here to get back to there? 1, 2, 3. But then I have to go back.
Yeah.
1, 2, 3, 4, 5, 6. So it's still going to be 3 over negative 6. It's still going to be negative 1/2.
Okay.
So slope will get you back to the line whichever way you go, right?
Okay.
Up and back or down and over. Same thing. How we doing? Okay, so I'm very excited. So now on the back, I think this is the part that somebody was asking about earlier. This is where you want to use the slope and the y-intercept. This is the quickest way to graph a line. So for 1A on the back. When we get done with this worksheet, we'll take a little break. I just sense that we're going to need a break. What's the slope from this line? Is this in the right form for me to see it?
Like a 0.
Not quite yet.
2 over 1.
Since this is this in the right form? What form do I have to be in to be able to see the slope and the y-intercept? I have to be in this form here. Where can I put it? mx plus b. Basically, y has to be by itself. This is why students don't trust this. It's too easy. Solve for y and everything falls into place. You don't trust that. Say, math is harder than that. No, that's the truth. You solve for y, everything falls into place. That is silly. That happens a lot when I'm talking about like equations for circles and all this kind of stuff, which is way far in your future. But still, if I solve the equation, I see all kinds of stuff in the equation. It just pops out at me. This happens a lot in math.
I think the part that's confusing me is you say you have to have y by itself, but the -3, which is b in the equation, is the y-intercept.
Because how do you get the y-intercept?
Well, I
Now
know
on
it's
this level,
-3,
you
right?
have to understand why it works, but then you accept it and move on. So you remember that b is the y-intercept, but you go back to y. How do you find the y-intercept? You
Make
set
x 0.
Yeah. What happens when you make x 0? Y
Goes
equals
away. Whatever b is.
y equals b.
Okay.
So that's why b is the y-intercept.
Okay.
You guys get that? So don't ever, that's what I was saying earlier, a lot of times students forget the connection between why the hell these are what they are, and then they just say, I was just told it was this, and that's when you start really losing interest. But I want you to realize there's a logical explanation for every damn thing I say. There is. So what's the slope? What's in the right place for the slope?
2 over 1.
Good, 2 over 1, I like it. So you make it into a nice ratio. Any whole number, you can make it automatically over 1. And the y-intercept in this case? -3. Just to be a little bit hard ass, the y-intercept is a point 0, -3. Cool.
Do you always want a slope as a function?
No, not necessarily, but it's a good idea because it goes along with the definition of slope being a ratio, rise to run. Right? So it's not a bad idea for yourself to put the 1 in there. So here's how I use this information to graph it very quickly. Stay with me now. I hear a lot of, what do I definitely know is on my graph? 0, -3. So you start there, and the slope. Now here's the cool thing about the slope. Anybody go hiking ever? Nobody goes hiking. You live in San Diego. You realize you're surrounded by hiking. So very often, if you go off the path, you want to know how to get back to the path, right? You're not supposed to go off the path, so don't. But if you ever accidentally go off the path, you want to be able to get back there. The slope tells me how to get back to the line always. If I start on the line and do what the slope says, I'll get back to the line. So you always want to start at a point you know is on the line, 0, -3. In this case, I know the y-intercept. And now what does the slope tell me to do? I want to rise 2, run 1. So rise 2, run 1. Let's do one more. Rise 2, run 1. Freaky ass little line, but that'll work. Are you guys cool with that? So we're sort of doing backwards. I gave you a line before, and then you counted up and over to get the slope. Well, if I give you the slope, you can count up and over to get the freaking line. It should work both ways, right? Who can tell me, well, first off, what point is this? Everybody should be able to tell me. What point is that? What is that point?
2, 1.
What should be true about that point because it's sitting on that line? It should do what if I put it into the equation? It should work, right? The line is a quick answer to the question, what are the answers to this? What are all the solutions to this? Any point that my line goes through should work here. So it's a nice check of your work to plug in a point that you get to and just make sure it works. If it doesn't work, you screwed up somewhere. Does it work? If I put in a 2, 2 times 2 is 4, minus 3 is, I get a 1. So when I put a 2 in, I do get a 1 out. Put a 2 in, I got a 1 out. It does work.
Even for the other numbers? For the other dots?
Yeah, it's got to. What's this one?
1,
One,
negative
1. Does it work? If I put in -1 for y and a 1 in for x, what's 2 minus 3? -1. So on one level, that's not too surprising, but on another level, it's so freaking cool. The line is supposed to be all the answers. So if you have to graph a line, how do you check yourself? Plug a freaking point in. It should work. This point wouldn't work. Otherwise, the line would find a way to go through it. You with me? So that's true about any shape. Right now, we've got a very lame shape. It's this shape, always. It turns around a little bit, but it's that shape. You probably know about that shape. Maybe, right? And then you have, different, you have this shape, you have that shape, whatever. But they all have the same idea. This point, whatever the equation is that makes that freaky ass thing, that point better work in that equation. Don't forget that. It's true, again, everything you learn in here is true in every damn level of math above this. Don't think it's only true here.
Are we going to learn those?
We're going to learn this one. Maybe not quite that one yet. But this one we'll learn, yeah. Yeah.
Okay, so if we solve for y, we can graph it without doing the chart. That's pretty much a shortcut.
There you go. That's why I said that's the quickest way to graph. The worst thing that could happen to you though when you try to solve for y is you get an ugly y-intercept. Can you imagine getting here -114 over 73? Okay, maybe I'm not going to do it that way. Maybe I will make an xy, but this should work for most of the ones we look at. Solving for y should make it nice. So what about the next one, part B? So first step is what? Can you see anything yet? Is the slope 2 and the y-intercept 4? Or is the slope 3 and the y-intercept 4? Or can you see anything yet?
Would the slope be 3 over 1?
Is it in the right form
Not
to see
yet.
something?
No.
What do you have to do first?
Get y by itself.
Get y by itself. Then everything falls into place. That's the only promise that this form makes, is if you do this, that will happen. Right? So we got to do that first. We got to get y by itself. How do you get y by itself? What do you do?
Subtract 3.
Subtract 3x. So again, I'm going to force this negative 3x in front because I know that's where I'm going to want it to be. That's a positive 4. Are you guys cool with that? Doesn't really matter, but sometimes you make the mistake of the first number is a slope and the next number is, that's not true. The number in front of the x will be the slope. The number by itself will be the y-intercept, so you got to be careful. Last step here is divide by 2. So you get y equals negative 3 halves x plus 2. So what's my slope?
Negative 3 over 2.
Negative 3 over 2, I like it. What's my y-intercept? 2. Be more specific. 0, 2. So again, where do I start? Always. Yeah, I start at a point on the line, and I know the y-intercept. That's all I know. So 0, 2. And what's the slope tell me to do?
Go
Down 3, 1, 2, 3.
And over 2.
Over 2, 1, 2. Now watch this. Let me see if you guys are cool with this. Mathematically, is there any difference between negative 3 over 2 and 3 over negative 2? Mathematically, they are both negative 1.5. So math says, I don't give a shit what you do, right? Wherever you want to put the negative, normally we put the negative on the top, but could I put it on the bottom if I really wanted to? Now, what does that do, though, to my slope? What then would it tell me to do from here?
Go up 3.
Go up 3
Back 2.
and back 2. But thankfully, see, I end up on the same line. So slope doesn't care which way if you go up and over or down and back. It doesn't care, and you can see that in the slope. The negative can be on the top or the bottom. Is that cool? Do you see that? If you don't, it almost doesn't matter, right? But it's a nice thing to realize. So then my line, let's see if I can do it again. Today's a good day for me in straight lines. And again, this was the one we knew. That's the y-intercept. What's got to be true? What point is this?
2 negative 1.
2, negative 1. What's got to be true about that point?
It fits into the equation.
It better work in that equation. And does it? Is 3 times 2 plus 2 times negative 1. Is that 4? You guys see what I'm doing?
6
2, negative 1. I plugged it in.
plus negative
6 minus 2 is 4. Thank God. So that's a quick check I could do to make sure that this came out right. Okay, good. Most everybody's awake. This is good. So finally, the last one. You see if I can cut to the chase a little bit here. I would add 2x over, and then divide by 5. Is that cool? Right, so solving for y shouldn't be that big of a deal. What's my slope and my y-intercept? Slope is 2 over 5. Y-intercept is 0, negative 3, 11. Got a few people converted to giving me a full point. I like that. So again, we do this to the point where it's old news and then it's not a big deal. What do you graph first? 0, negative 3. And then it tells you to go up 2 over 5. Oops. 1, 2, 3, 4, 5. So it should be right there. That's crazy. That's a good day for straight line. How can I check my work real quick? Besides plug it into a graphing calculator. Be careful, I'm not going to let you use a graphing calculator on the...
Plug in 5, negative 1 to the equation.
Yeah, that's the point. 5, negative 1. If I plug it in, be careful here. 5 goes in for what?
The x.
The x. So 5 times negative 1, that's the y, minus twice 5. Sure enough, that's negative 5 minus 10 is negative 15. Check. So I know I'm good. Okay, cool. So let's take a break. Come back 15 after, because I'm not going to keep you here too long.